So whenever we draw graphs, we say y is equal to fx. This is the first graph. We draw the curve. We draw the curve. Then if we do dy by dx, we are finding the slope of the tangent in terms of theta, and tan theta is the slope is m. So y is equal to mx plus c. That's same thing, m. That is x theta with the horizontal axis. Tan theta, it gives you the slope. So the thing you have to remember is that if tan theta, if you see the curve of tan theta, you will have even that curve is an asymptote at 90, and this is 90 degree, and then from 90 to 180 it again follows the same period. So from when it's acute, when the angle is acute, theta is acute, then it is positive, and when theta is obtuse, it is negative. This gives you the slope of the tangent. Now here in 1 by x, y is equal to 1 by x. So y is equal to x raised to power minus 1. So if I do dy by dx, I follow the rule that if y is equal to xn, dy by dx is equal to nxn minus 1. So this will become minus 1 x minus 1 minus 1. That's minus x 1 over x square. This is positive. This is negative. So here dy by dx is always negative. If it's always negative, then it has to be always obtuse. Take any point, take any tangent anywhere, take a point, draw a tangent, see the angle with respect to the horizontal, you'll find it obtuse. Take a point, draw a tangent. With respect to the horizontal, it is obtuse. Take a point, any other side, draw a tangent. With respect to the horizontal, you'll find it obtuse. Take a point, draw a tangent. With respect to the horizontal, you'll find it obtuse. Always obtuse. That's why this shape is there. The dy by dx is always telling me that the slope will always be obtuse. You take any point, draw at any point, any tangent, see this orientation with respect to the horizontal line. So this shape matches the first derivative. Then comes this first thing. Whenever we draw a graph, you first draw the curve by y is equal to fx. Second, you draw the dy by dx. Do dy by dx to get an idea of the slope of the tangent. Third, the second order derivative. Now this is the rate of change. This is the rate of change of this. So, so this was the rate of change of y with respect to x. This is the rate of change of dy by dx with respect to x. Okay. Now, one thing is very clear that in maxima, the rate of change is negative. Why? Because dy by dx moves from acute angle to obtuse angle. So if dy by dx is changing from plus to minus, if dy by dx is changing from plus to minus, means that the second order derivative is negative. So that means this is why the second order derivative, if it comes out minus, it is maxima. In minima, the opposite happens. Minima is here. Here dy by dx is the slope of the tangent here. This is obtuse. And it moves to the other side. It is acute. So it's moving from negative to positive. So whenever dy by dx moves from negative to positive, d square y by dx square is positive because it's going from a negative value into positive value. The rate of change of this is positive. That's why d square y by dx square is positive. It is a minima. Then there's another thing. This is about the maths. What about the visualization? The visualization is if dy by dx is the slope of the tangent, second order derivative is the curvature of the curve. Now you will gradually come to know this. I will make you feel it with different examples. Right now, I'm just telling you that if it concave down, if it is concave down, in physics, you have a concave lens, right? It's kind of this. So if it's concave down, then d square y by dx square is negative. Second order derivative is negative. If it's concave up, then the second order derivative is positive. See, here it is concave up. So at minima, it is concave up. That's why it is positive. And here in this curve, in the reciprocal graph, I told you y is equal to 1 by x. I told you dy by dx is equal to minus 1 by x square. What was the third derivative? I again do it. So this is minus x minus 2. I again differentiate it. It will become minus into minus 2 into x minus 2 minus 1. That's 2 by x cube. Now, what do I notice? One thing that if x is positive, it will become second order derivative will become positive. That means it will be concave up. That's why in the positive part, it's concave up. And in the negative part, because if you take x as minus 1 negative, this will become negative. That's why it is concave down. Any curve, any graph, from now on, I'm going to tell you, will have all these components and I will relate all of them for you. Then you will remember the curve forever. You won't forget. Did you understand a bit?